Hello, my name is Rob Reynolds. Welcome to Business Calculus section 1.3. I just want to remind you of a couple things before we get started for this lesson. I'd like to remind you to go to Blackboard and download the notes that have been provided for this video that will help you walk along the problems. As I'm working them, you can be working them on a worksheet. So go and print off a worksheet off of Blackboard. Also, don't forget that you can ask me questions by shooting me a quick email within WebAssign, and then I'll shoot you back a response. This particular student had the correct answer when they were using the quadratic formula. They were just typing in a decimal answer, and her question, in essence, was just how to convert on your graphing calculator. How do you convert a decimal back into a fraction? And the answer is math, enter, enter. So again, I'm going to continue teaching you how to use your graphing calculator. So and you'll need one for this course. So go purchase a TI-84, and then I'll continue teaching you throughout the course. So today's lesson is about lines and graphs and equations of lines, which I've talked a little bit about, but we're going to look a little bit more in depth of it today. So we're going to talk about slope, how to sketch some graphs real quick, how to write equations given 2 points. And point slope form is a useful form. I don't use it a whole lot, but we'll use it when we get to the conic section, graphing ellipses. Parallel lines, here's the symbol for parallel lines. Two lines that never intersect, perpendicular, have a right angle, and their slopes are the same for parallel. And then here, if the slope is 2/3, the perpendicular slope would be the opposite reciprocal. And then we're going to look at, again, how this applies in real life to a business calculus major. So the simplest form of equation of a line is y equals mx plus b. This is called a slope-intercept form because m is the slope and b is the y-intercept. And sometimes I call the b the start value because that's where you start graphing the line. So if y equals b, so like if y equals like the y-intercept of just 5, then you just get a horizontal line at y equals 5 because no matter where you are, there's 1, 5. Here's maybe the point 6, 5 on that line. No matter what, y will always be 5. Now, I might as well pause here and just remind you real quick. It's kind of confusing. This is the x-axis right here, but the equation of this line is y equals 0 because if you plot any point on the x-axis, the y value will always be 0. And then likewise, this is the y-axis, but it's confusing to students because the equation of this line right here is x equals 0. So any point on here you could think about being 0. Maybe that's the point 0, -3. So a line that crosses the y-axis that's called the y-intercept. Now here's positive slope. You read a line like you read a book from left to right. So this m would be positive and this m would be negative slope. You could think about, again, just reading that line from left to right. If this line goes up from left to right, it's positive, and if the line falls or goes down, it's negative slope. Non-vertical lines are really not even functions, but this would be this would be a vertical line, x equals 5, and that's a special case where I'm not going to be able to write it in this y equals mx plus b form because there is no y. So the equation for vertical lines is just x equals something. Again, m is defined. If m is undefined, if the slope is undefined, then we know that we have a vertical line. Now, one way to remember that is you could write the word no. There's no slope. So if you can write the n, I don't know if you can see that or not, but that vertical line is part of the n. So sketching the graph of this, again, I like to call this the start value or the y-intercept. So that's where you start on the y-axis at 1, and then the slope is rise to run 1, and I would do that over and over again. And instead of going up and to the right, you could go down to and to the left. And sometimes students say they need a straight edge, but if you just fill up your graph, you can get a pretty good straight line, but you can always use your credit card or your school ID the line as well. Here's the line y equals 2. No matter where you have, well, no matter what x is, y will always be 2. And the easiest way to graph this one, which I think I shared in a earlier video, is just x and y intercepts. So to find a y-intercept, you let x be 0. So the y-intercept, if you let x be 0 here, y will equal 2. So that's called a y-intercept. And then likewise, if you let y be 0, you're finding an x-intercept, and the x-intercept's at 2, and 2 points determine a line. I think I've also mentioned to you about monkeys wouldn't prefer apples over bananas. I like that. That's that negative a over b. In this case, a is 1, b is also 1, so just negative 1 over 1, which you can see that really is the slope. Down 1 over 1, down 1 over 1, down 1 over 1, and that continues. Again, here are just some worked out solutions that you're welcome to view off of Blackboard. With regards to business calculus and how this is going to apply to you, oftentimes you'll have in the real world this word called a rate of change. And I want you to recognize rate of change as just slope. You need to make sure that the slope has the same units. Otherwise, we don't want to call it a ratio, or that's the difference between a ratio and a rate. A ratio would have the same units like kilometers or kilometers. A rate would be like kilometers per mile or kilometers per meters. Maybe this M stands for meters instead of miles. But you could do 5 kilometers per 3 miles, probably. But if it has different units, then we're going to refer that as a rate. So in this example, you can see that the rate is 25, and what that means is that's probably money if we're talking about a product here. This $3,500 tells you the start value of this, how much money you're going to invest at the start value. So if you just sell no t-shirts, if I have a t-shirt company, if I sell no t-shirts, that's 25 times 0. It's still going to cost me $3,500 to have a t-shirt factory, and if I don't sell any, just because of startup costs, electricity, and paying employees. So that's the cost of producing no units or no t-shirts. Again, the 25 would be the cost of producing each unit. So each t-shirt, that's interesting, it's an expensive t-shirt, is going to cost $25. And here's a visual of that. So these are called just fixed costs, or the startup value, and then the cost of producing each t-shirt increases as I continue creating more and more t-shirts. Now that's just the cost. But remember, that's not revenue and that's not profit. That's just the cost of producing the t-shirts. So to find the slope of the line, there's a couple ways to do it. If I give you 2 points, I would prefer you use y minus y over x minus x. And if I give you a graph, let's use rise over run. They are both great definitions, but if the graph is already drawn for you, you can just simply do the rise over the run. And then maybe this is 5 and this is 7. We would say that the slope is 5/7, probably the fastest way. But if they don't give you a graph, then you'll have to do the change in y over change in x. Sometimes they get worried about this y sub 2 minus y sub 1. And it really doesn't matter if which order you subtract them in, just be consistent. So again, this is a delta symbol in math. It just means change in y, the difference in y. And again, the order that you do this in doesn't really matter to me. Just make sure if you start with y sub 2 in the numerator, you cannot switch to x sub 1 in the denominator. It will be incorrect. So go ahead and pause the video and see if you can find the slopes of these. So if you have your handout, go ahead. Since I gave you 2 points, let's use this equation, y minus y over x minus x. And I'll do it exactly like the book wants you to do it. Y. So here's x, y, here's x, y, and I'll start with y sub 2, although it doesn't really matter. 1 minus a negative 2. It's the y. Whoops. Let's try a 0 for the y value. Sorry. Sorry. There's the y values in yellow. And then I need to subtract consistently, I need to go back. So if I started with point B, I need to go back to point B. So 3 minus the negative 2 is in the denominator down here. So that's 1/5. This is interesting because when you do y minus y, you'll get 0, and 0 divided by anything should be 0, unless it's 0 divided by 0, which we'll talk about later in calculus, but not now. This will be -1 minus a 4 over 1 minus 0, which is -5 over 0. So yes, you can have a slope of 0. And then down here, I think we have a situation where you have some number, it doesn't matter what it is, divided by 0. And my Algebra 1 teacher told me if 0 is under, it's underdefined. In other words, there's no slope. In other words, that's a vertical line. And up here was a horizontal line. So again, no slope means undefined. You can't divide by 0. If 0 is under, it's underdefined. And then if it's horizontal line, I didn't show this to you yet, but you can remember that by saying, oh, you can literally write the word 0 from a horizontal line. And so here are some worked out solutions, which if I'm going too fast, you can go to Blackboard and check out the PDF files listed there. All that is required to graph a line is slope and 1 point. And given slope and 1 point, we can graph any line. And sometimes we have to do a little bit of work to find the slope by doing y minus y over x minus x. Here's a point slope version. And I told you already I'm not the biggest fan of that because I can avoid that through this whole section. But if WebAssign makes you use this form, then I certainly will help you. But we don't leave, the reason why I'm not a big fan of this is we don't leave answers in this form. If you happen to do point slope form, always convert it back to y equals mx plus b when you type in the final answer. So I'll probably show you a method. You don't even have to use it. So given the slope of 3 and the point, well, I'll do it both methods, and you can decide which method is better. The book wants you to do y minus y is equal to slope x minus x. I would recommend that you just go to y equals mx plus b because, well, that's the final form of the answer that we want it to be in anyways. So over here, we would do y minus this y value of a -2 is equal to the slope x minus 1. But of course, you can't leave it like this. So you have got to do a lot of work, clean this up by distributing and maybe subtracting off 2 from both sides. So let's see if we can get the same answer over here. And I think you might like this a little bit better. So I need a y, and there's a y value, -2. I'll just start plugging things in. I know the slope, and I even know x. All I need to do over here is solve for b by subtracting off 3, and I get -5. And lo and behold, I've got slope, which is that 3. I've got what? Those are the 2 things required, so I could write the equation of the line 3x minus 5. In my opinion, that's less work and less opportunity for you to make mistakes. But you're certainly welcome to use point slope form if you'd like, but I'd choose slope intercept. So again, here's how the book wants you to work it out. I would recommend a little bit different. Since this is a business calculus, there's going to be some word problems where it's just not going to be as black and white for what you to do. So you have to read and understand what's going on in the problem. After 7 years, well, we'll let time be 0 at 2000. So I'll just say after 7 years, this price was $1.43. That's some point in time. And then 1 year later, we'll call that 8. It was 155. So I had to actually generate the 2 points. And then from there, I could find my slope again, 1.43 minus 1.55 over 7 minus 8. I think this will turn out to be around 0.9. No, 0.12 maybe. You can work that out and make sure. Once you determine that that's 0.12, actually, if you pull out your calculator, I can teach you one more thing. This is a neat trick, so you don't have to use parentheses because the mistake that some people will make is 1.43 minus 1.55 divided by 7 minus 8, and that will give you a wrong answer. So teaching you a little bit why does that give you a wrong answer? Because your calculator thinks you wanted to do 1.43 minus 1.55 divided by 7 minus 8, and that's not what you wanted. That's what you typed in, and that's what your calculator thought you wanted because you didn't put any parentheses. But instead of using parentheses around the numerator and the denominator, which you certainly could, I'll show you, but for sake of time of the video, I don't know, I always get kind of bent out of shape when my videos are longer than they should be because I feel like you don't want to watch them. That's one way to type it in. I would encourage you, instead hit second y equals, and then that'll give you a quick little fraction. I love this method because students don't type things in wrong when they use this little fraction key. So you can see I get the exact same answer, 0.12, but boy, I sure do like that second method. Once you have the slope as 0.12, then we can use any point, either point A or point B, doesn't matter. I'll choose A, the numbers look smaller, and I'll go to my y equals mx plus b, and you're certainly welcome to do y minus y is equal to slope x minus x point slope if you'd like, but I'm going to pick off a y value here, and I'll pick off the x value here, and just start plugging things in. Oh, and by the way, I've got the slope here, so I have everything I need except for the y-intercept, but I think I can solve for the y-intercept. Plug in the slope of 0.12, the 7, multiply that out, subtract it off, and I think b turns out to be 0.59. And then so I can write the equation. Y is equal to over some time plus this 0.59, but then reading, oh no, it says make a prediction. So after you write the equation, make a prediction, and that says well, I'm going to let time be 9. So I need to do a little bit more work to actually answer the question, what would y equal after 9 years? And I think that turns out to be like around 1.67. And again, you're welcome to look at Blackboard for how they worked it out. So I use these slides for teaching in class as well, so face-to-face classes. So since I'm teaching this on a video, I'll try to just move along here. When you're making predictions about things that are happening in between 2 points, so maybe you're given point A and you're given point B and you're trying to estimate what's going to happen in between those 2 points as time goes along, that's called interpolation. If you're making a prediction about the future way out here, about you don't have any data, but if this trend continues, that's extrapolate. So we're going to see if we can make predictions. And then the last form, the general form, sometimes this is referred to as standard form of the equation of a line. So there's 3 equations of lines that we're learning about today. And then don't forget about this vertical line. Probably not given in that form. It's usually given in this form, but it's the same thing, x equals some value. So here's just a quick summary of the different types of lines that we're looking at. I already mentioned parallel lines have same slope, perpendicular have opposite reciprocal. So here are examples of what that might look like. Example 7. If I use monkeys wouldn't prefer apples over bananas, parallel, I want to find parallel to this line, so negative a over b, and this is in the form ax plus by is equal to c, standard form. So I'll just pick off negative 2 over negative 3 and tell you that the slope is 2/3. That's 10 times faster than what the book or any other algebra teacher asks you to do, which is spend the time to solve for y. And so if you want to do that, you can. There's nothing wrong. I would never count anything off on a quiz or a test. But to divide every term, oh my gosh, this just takes so much time to find out that the slope is 2/3. So this gives you a little bit more information. Of course, we can graph a little bit. I didn't need that y-intercept. I was really just looking for that slope of 2/3. So if you learn this definition, monkeys wouldn't prefer apples over bananas, which I taught in an earlier lesson, that would really save you some time. So now I want to find the equation of a line that passes through this point and has this slope, which is the same slope. So I will go to y equals mx plus b, the y value, slope, x, and b, and I'll solve for b, which turns out to be negative 5/3. You can check my math there. I wanted to talk about perpendicular slope. So if the slope here, monkeys wouldn't prefer apples over bananas, negative 2/3, positive 2/3, because it's the opposite of this over this number. And remember, this number is actually negative 3. So that's a positive 2/3. So perpendicular slope to that would be opposite reciprocal. Well, the reciprocal is 3/2, and the opposite of positive is negative. So then I would write the equation, y is equal to negative 3/2 x plus b, and using this same point, plug those values in for x and y and solve for b. And again, I'll leave you up to seeing if you can use your graphing calculators to type this in. Well, I really would. It's what? Negative 1, you're going to be adding plus, what is that? If 3 times 2, 6, divided by 2. Well, good grief, I was going to show you how to do math in or but that's not even a fraction. So if the b value is just a 2, then we could just write the equation y is equal to negative 3/2 x plus 2. I should have shown you up here, maybe. Maybe I'll show you this one, because this one turned out to be a fraction. So I'll type this guy in right here. If negative 1 is equal to 4/3 plus b, then again, on your calculator, I'll type in negative 1 minus 4/3. And then if I hit math, enter, that'll, nope, didn't do that right. So I can go back up, sorry. Try that again, press enter, and then hit math, enter. And that'll convert it to a fraction. Ooh, maybe that's not negative 5/3, maybe it's negative 7/3. Well, let's see what the author has. I might have done that incorrectly. Oh, the negative 5/3 was, I'm so sorry, the negative 5/3 was the y-intercept for that line when they're finding me the slope. I think the answer for this, there it is, was the negative 7/3 for part A. There it is. So here's part A worked out once you know that the slope and the y-intercept. So good, we found an error. If you read something that has depreciation, that just means it's going to have some negative slope going on, and the example of that would be for number 8. Again, at times 0, it starts at $12,000, and then 8 years later, we're at $2,000. So you can see that's really declining pretty quick. You can go ahead and find the slope and write the equation of this line. V is equal to negative, there's the slope, t plus b. And then it does not matter if you plug in point A and B, but you can solve for v, and I'll believe you'll get something close to 12,000. And again, I went through that a little bit fast because I'd like to finish this video, but if you'd like to look at the PDF file online, there's the worked out solution. Right here's how the author worked it out. If you have any questions about this video, feel free to shoot me an email. I hope this was helpful.